Good day. Today we're going to learn about the different forces acting upon the Earth, forces and processes who is responsible for the changes in our planet. Our objectives this day: define endogenic and exogenic processes. Identify examples of endogenic and exogenic processes, difference between the two processes, and explain how these forces shape and change the Earth's surface. The Earth is not static. It is a dynamic and ever-changing planet. The surface we see today has been shaped over millions of years by different natural processes. Today we will explore the dynamic processes shaping Earth, focusing on these two geologic forces, the endogenic and exogenic forces. Let's dive into the fascinating world of geologic forces, which are the natural processes responsible for shaping and changing the Earth's surface. There are two main types of these forces. First, we have endogenic forces, which originate from within the Earth. These internal forces play a crucial role in building up the Earth's crust. On the other hand, exogenic forces come from outside the Earth. They work on the surface, breaking it down and shaping it over time. By understanding these two types of forces, we gain insight into how the dynamic processes of the Earth continuously mold our planet's surface. Endogenic processes are fascinating because they originate from beneath the Earth's surface, driving the creation and alteration of our planet's structure. These internal forces are crucial in building up the Earth's crust, leading to the formation of significant landforms such as mountains and volcanoes. One of the most remarkable effects of endogenic forces is their ability to not only create, but also raise and reshape the Earth's surface. This dynamic process is essential in understanding the ever-changing nature of our planet. By comprehending these internal mechanisms, we gain insight into the processes that have sculpted the Earth over millions of years, laying the groundwork for the diverse landscapes we see today. Magmatism is the process by which magma, molten rock beneath the Earth's surface, forms, moves, and solidifies.
1. Formation. Magma forms deep inside the Earth when rocks melt due to high temperature. Pressure changes, like when rocks rise and pressure decreases. Addition of water or gases, which lowers the melting point. 2. Movement. Because magma is less dense than solid rock, it rises upward through cracks and weak zones in the Earth's crust. 3. Cooling and solidification. Magma can cool below the surface, forms intrusive igneous rocks, e.g., granite. Reach the surface as lava, forms extrusive igneous rocks, e.g., basalt. In short, magmatism is the creation and movement of magma that eventually forms igneous rocks and can lead to volcanic activity.
Metamorphism is the process where existing rocks change in form, structure, or composition because of heat, pressure, and chemically active fluids, without melting completely. Simple explanation. Think of it like this. A rock is remade inside the Earth due to extreme conditions, but it stays solid the whole time. What causes metamorphism? Heat. From deep inside the Earth, or nearby magma pressure, from layers of rock pressing down, or tectonic movement fluids, hot water with dissolved minerals that help change the rock. What happens to the rock? Minerals rearrange and form new patterns. The rock becomes denser and harder. New types of rocks are formed called metamorphic rocks. Examples: limestone, marble, shale, slate, granite, gneiss. In short, metamorphism is the transformation of existing rocks into new rocks due to heat and pressure, without melting them completely. The rock cycle is a continuous, geological process that recycles Earth's rocks over millions of years, transforming them between igneous, sedimentary, and metamorphic types. Driven by internal heat and surface weathering, it involves melting, erosion, compaction, and heat/pressure to change rock textures and mineral compositions. 3 primary rock types and transformation processes. Igneous, forms when magma or lava cools and crystallizes. Sedimentary, forms when rocks break down, weathering, move, erosion, and are cemented together. Metamorphic, forms when existing rocks are altered by intense heat and pressure. Volcanism or volcanism. Volcanism is the process where magma from inside the Earth rises, erupts onto the surface as lava, and forms volcanic features. In simple terms, it is what happens when a volcano erupts and releases lava, ash, and gases. Key idea: magma escapes to the surface, becomes lava, creates volcanoes, lava flows, and volcanic rocks. Plutonism is the process where magma cools and solidifies underneath the Earth's surface without erupting. In simple terms, it is when magma stays below ground and slowly hardens into rock. Key idea: magma does not erupt. It cools slowly underground, forms intrusive igneous rocks like granite. Here is a simple explanation. 1. Plates move. Earth's surface is made of plates that move because of heat and convection inside the Earth. 2. Plates move apart. Divergent. Plates separate, magma rises, and new crust and volcanoes form. 3. Plates slide past, transform. Plates slide sideways, causing faults and earthquakes, few volcanoes. 4. Plates collide, convergent. One plate goes under another, melts, and forms volcanoes. 5. Hotspots. Magma rises in the middle of a plate, forming volcanoes. Older ones become extinct as the plate moves.
Here are some examples of endogenic forces that play a crucial role in shaping our planet. We have earthquakes, volcanic eruption, continental drifting, and mountain building. These endogenic forces are dynamic and powerful, continually reshaping the Earth's surface and providing the foundation for life as we know it. First, let's talk about earthquakes. These sudden movements of the Earth's crust occur due to the release of built-up stress along geologic faults or by volcanic activity. An earthquake is a sudden, rapid shaking of the ground caused by the release of accumulated strain energy in the Earth's crust. It results from the abrupt movement of rock, usually along tectonic plate boundaries or fault lines, which produces seismic waves that shake the surface. Destructive earthquakes in the Philippines, often known as killer quakes or major tremor events, are frequent due to its location on the Pacific Ring of Fire. Here are some of the most destructive earthquakes in the Philippines. 1976 Moro Gulf earthquake, magnitude 8.1, the strongest recorded earthquake in the country. It struck Mindanao on August 10, 1976, triggering a 9-meter tsunami, killing approximately 8,000 people. 1990 Northern/Central Luzon earthquake, magnitude 7.8, struck on July 16, 1990, causing major destruction in Baguio City and nearby provinces with over 2,400 deaths. 1645 Luzon earthquake, magnitude 7.5, known as the most terrible earthquake in early Philippine history, which devastated Manila. 2013 Bohol Cebu Siquijor earthquake, magnitude 7.2, occurred on October 15, 2013, destroying historic churches and infrastructure in the Visayas. 1968 Casiguran earthquake, magnitude 7.3, caused widespread damage to parts of Luzon, including Manila. 1994 Mindoro earthquake, magnitude 7.1, caused significant destruction and triggered a tsunami. 2019 Luzon earthquakes, magnitude 6.1 and 6.9, hit Zambales and Davao del Sur respectively, causing significant structural damage. 2025 Davao Oriental doublet quakes, magnitude 7.4 and 6.82, powerful earthquakes in October 2025. Next, consider volcanic eruptions. These are dramatic demonstrations of the Earth's internal heat and pressure, where molten rock, ash, and gases escape through vents in the Earth's crust. They not only create new land but can also significantly alter existing landscapes. A volcanic eruption is when gas and/or lava are released from a volcano, sometimes explosively. A fissure volcano is a linear volcanic vent or crack, often kilometers long, through which lava erupts, typically without explosive activity. The Philippines has over 300 volcanoes, with roughly 24 to 50 classified as active, according to the Philippine Institute of Volcanology and Seismology, PHIVOLCS, and the Smithsonian Institution. The most active volcanoes, including Mayon, Tal, Bulusan, Canlaon, and Pinatubo, are frequently monitored for eruptions. Major active volcanoes in the Philippines. Mayon volcano, albeit known as the most active, renowned for its perfect cone shape. Tal volcano, Batangas, a highly dangerous, active caldera lake. Pinatubo volcano, Zambales, Pampanga Tarlac, famous for its 1991 eruption. Bulusan volcano, Sorsogon, frequently active. Canlaon volcano, Negros Island, active volcano in the Visayas region. Ragong volcano, Llano del Sur/Cotabato, active Mindanao volcano. Haibok volcano, Camaguan, active volcano. Smith volcano, collective in the Babuyan group. Mujuan Peak, Bukidnon, active volcano. Biliran volcano, Leyte, active caldera. Did you know that on June 15, 1991, one of the largest eruptions of the 20th century happened in Pinatubo volcano. This eruption produced eruption column that led to heavy ashfall, pyroclastic density current, pyroclastic flows, and lahars. These volcanic hazards affected more than 200,000 families and the indigenous Ida people.
Continental drifting is the gradual movement of the Earth's continents over geological time, driven by plate tectonics. It leads to the formation and breakup of continents, impacting the global climate and biological evolution. In 1912, Alfred Lothar Wegener, German climatologist, geologist, geophysicist, meteorologist, and polar researcher, states that all continents were once joined together in a single massive landmass and have since drifted apart. The supercontinent was named Pangaea.
Pangaea, in early geologic time, a supercontinent that incorporated almost all the landmasses on Earth. Pangaea was surrounded by a global ocean called Panthalassa, and it was fully assembled by the early Permian epoch, some 299 million to about 273 million years ago. Did you know that? The Philippines is officially composed of 7,641 islands. This total, updated from the previous count of 7,107, was verified by the National Mapping and Resource Information Authority (NAMRIA), using advanced high-resolution radar mapping, which identified over 500 previously undocumented, mostly small and uninhabited islets.
Lastly, we have mountain building, or orogeny. This process involves the collision and compression of tectonic plates, resulting in the uplift of mountain ranges. Mountain building results from a variety of geological processes. The largest mountain ranges form over millions of years as tectonic plates collide, or as one tectonic plate overrides another plate.
Exogenic forces are quite different from the endogenic forces we've just discussed. These forces originate from outside the Earth's surface and include external factors such as water, wind, and temperature. They're responsible for wearing down existing landforms and play a crucial role in transporting and depositing sediments. In essence, while endogenic forces build and shape the Earth's crust, exogenic forces work to break it down and redistribute materials. This dynamic interplay between the two types of forces is essential in shaping our planet's surface. Next, we'll explore specific examples of these exogenic forces and their significant impact on our environment.
These are the different examples of exogenic process: weathering, erosion, mass wasting, and deposition. These processes work together to continuously reshape the Earth's surface, creating the dynamic landscapes we see around us today.
Weathering. This is the gradual breakdown of rocks and minerals at the Earth's surface. It can happen through various means like temperature changes, water action, and even biological activity. First, mechanical weathering. This involves physical forces breaking rocks apart. A great example is the freeze-thaw cycle, where water seeps into cracks, freezes, and expands, causing the rock to fracture. Next, we have chemical weathering, which involves chemical reactions that alter rock structures. Think of acid rain. It reacts with minerals like limestone, dissolving them over time. Lastly, there's biological weathering. This is where living organisms play a role. Imagine tree roots growing into rock cracks, eventually splitting the rock apart as they expand. These processes work together to gradually transform rock surfaces, preparing them for further movement and reshaping by other exogenic forces. Whether it's the slow but steady growth of a tree root or the powerful expansion of ice, each example highlights the relentless and transformative power of weathering in our natural world. When we talk about erosion, we're discussing a powerful natural process that shapes the very landscape around us. Erosion involves the wearing away and removal of soil, rocks, or land surfaces by forces such as water, wind, ice, or gravity. Let's start with water erosion. Think of rivers carving out valleys and canyons over thousands of years. Water is a relentless force, cutting through rock and soil, transporting sediments to new locations. Next, wind erosion. In arid regions, wind can pick up loose particles, like sand, and create stunning formations like sand dunes. Wind is a sculptor, constantly reshaping the environment. Finally, glacial erosion. Glaciers, massive rivers of ice, grind down rock surfaces as they move. This process creates breathtaking landforms, like fjords, and U-shaped valleys. Mass wasting / landslide definition. The downslope movement of weathered rock and soil, often referred to as landslides or mass movement, differing from erosion in that it does not require a transporting medium like water or wind. Causes and triggers. The primary force is gravity, but triggering factors include water saturating the slope, earthquakes, volcanic eruptions, vegetation removal, and human engineering, e.g., cutting roads into slopes. The role of water. Water is the most common trigger, reducing the shear strength, internal friction, and cohesion of material. Deposition. This is the process where sediments, soil, or rocks are finally laid down in a new location after being carried away by natural agents, such as water, wind, or ice. Deposition is crucial because it creates new landforms and is a part of the continuous cycle of erosion and deposition that shapes our planet's surface. It can lead to the formation of features like deltas, sand dunes, and beaches. Keep in mind that this process contributes to the diversity of landscapes we see around the world and plays a significant role in ecological systems by providing habitats. As we transition to our next slide, we'll see a real-world example of how deposition and other natural forces shape our environment.
Exploring a real-world example, the Himalayas. Formation of the Himalayas. Begin by explaining how this vast mountain range was formed. It emerged from the collision between the Indian plate and the Eurasian plate, a phenomenon known as endogenic activity. Influence of exogenic forces. Next, transition to the ways in which exogenic forces have shaped these mountains. These include river and glacial erosion, wind, and landslides. Each of these factors contributes to the continuous transformation of the landscape. Aside from the Himalayas formed by tectonic activity, endogenic, we also the Grand Canyon shaped by the Colorado River, exogenic. Local environments exhibit these processes, with evolving hills and riverbanks. The interplay of these forces fosters diverse ecosystems, demonstrating the balance between creation and erosion over time. Observing nature reveals Earth's transformation and the effects of climate change and human activities. Understanding these processes deepens our appreciation for the planet's dynamic nature. Endogenic processes come from inside the Earth. They are driven by heat and energy beneath the surface. Examples: earthquakes, volcanic eruptions, mountain building. Effect: they usually build up landforms like mountains and volcanoes. Exogenic processes happen on the Earth's surface. They are caused by external forces like water, wind, ice, and gravity. Examples: erosion, weathering, landslides. Effect: they usually break down or wear away landforms.
The Earth's surface is constantly being reshaped by a balance between endogenic internal and exogenic external processes. They don't act separately. They interact over time to build, destroy, and reshape landforms.
The Earth's surface is dynamic, endogenic forces build landforms, while exogenic forces modify and reshape them over time.
The Earth's surface is constantly changing due to the interaction of endogenic and exogenic forces. While internal forces create and uplift landforms, external forces gradually wear them down and reshape them. Understanding these processes helps us explain natural phenomena such as earthquakes, volcanic eruptions, landslides, and the formation of landscapes around us.